For example, there is 8 cardiomyocytes from endocardium to epicardium, there is negative electrode and there is positive active electrode. In resting state, all cells have positive charge. Again, by positive charge we understand the charge on the outer surface of the cellular membrane. And because electrodes measure only the difference in electric potentials, and we see there is no any minus charge cell, so there is no difference in electric potentials, active electrode registers just isoelectric line. But when electric impulse reached the first cell depolarized, the charge became negative. So there is one depolarized cell that have negative charge and 7 non-depolarized cells that have positive charge. And now this negatively charged depolarized cell creates the difference in electric potentials with formation of the vector of depolarization. Vector shows the movement of charge, but to simplify, vector is the line from minus to plus. So basically vector is the line from depolarized cell to non-depolarized cell. So we have 1 negatively charged and 7 positively charged cells that creates the small vector of depolarization, and active electrode registers that and depicts a small initial elevation from isoelectric line. As depolarization proceeds to the second cell, the difference in electric potentials in tissue increase, and when the second cell became depolarized, the vector of depolarization increased, because now there is 2 negatively charged cells and 6 positively charged cells, so the tissue between electrodes became more electrically different, and active electrode depicts this as increase in elevation from isoelectric line. The same principle with third cell. Third cell depolarized, the charge became negative. Now there are 3 negatively charged cells and 5 positively charged cells. The vector of depolarization increased due to increase in difference in electric potentials, and active electrode depicts this as increase in elevation from isoelectric line. And when the fourth cell became depolarized, the electrode depicts the maximal elevation from isoelectric line, because now there are 4 negatively charged cells and 4 positively charged cells, and when half of tissue have positive charge and half is negatively charged, there is the maximal difference in electric potentials that forms the maximal vector of depolarization, and this results in maximal elevation from isoelectric line. But when depolarization proceeds to the fifth cell became depolarized, the elevation decreased, because now there are 5 negatively charged and 3 positively charged cells. So tissue became more electrically negative, so the difference in electric potentials decreased, so the vector decreased, and the active electrode registers this as decrease from the level of maximal elevation, but still there is substantial elevation above isoelectric line. And as depolarization proceeds further to the 6th cell and 7th cell, the tissue became more and more electrically negative, so the difference in electric potentials decreased, so the elevation above isoelectric line decreased. For example, at this point, there are 7 negatively charged and 1 positively charged cell, so there is minimal difference in electric potentials, so the vector of depolarization became minimal. So active electrode at this point registers minimal elevation above isoelectric line. And when the 8th cell depolarized, all 8 cells became negatively charged, and there is no any positively charged cell, so there is no difference in electric potentials, and the active electrode registers this as isoelectric line. And after depolarization, cell begin to repolarize. There are the same 8 cardiomyocytes from endocardium to epicardium, its negative and its positive active electrode. After depolarization, all cells have negative charge. And there is the most tricky concept. Logically, the first cell that have to restore the positive charge is the cell that depolarize first. But this works only if all cells have the same duration of an action potential, like for example skeletal muscles. But in cardiomyocytes, repolarization begins from the most epicardially located cell, because epicardial cells restore their positive charge earlier than endocardial cells. This concept will be explained in more details, but if a cell repolarize and restore its positive charge, at this moment there are 7 negatively charged cells and 1 positively charged cell, so now there is a small difference in electric potentials with formation of the vector of repolarization, that is orientated from left to right, in the same fashion as the vector of depolarization, Because the vector is aligned from minus to plus or from depolarized to non-depolarized cell, and the active electrode registers this as minimal elevation from isoelectric line. As repolarization proceeds further, the difference in electric potentials increase and became maximal when the fourth cell restores positive charge, because at this moment there are 4 negatively charged cells and 4 positively charged cells, so the difference in electric potentials became maximal, and vector of repolarization became maximal, and that's why active electrodes at this moment register maximal elevation from isoelectric line. From this moment, the more cells restore their positive charge, the lower will be elevation above isoelectric line. For example, at this point there are 1 negatively charged cell and 7 positively charged cells, so there is minimal difference in electric potentials, so the vector of repolarization became minimal, and the active electrode registers this as minimal elevation above isoelectric line. And when the first cell repolarizes, all 8 cells have positive charge, and there is no cells with opposite negative charge, so there is no difference in electric potentials, and the active electrode registers this as isoelectric line. The reason why epicardial cells repolarize first is the duration of an action potential. The central concept is that endocardial cells have a longer action potential than epicardial cells, and the more epicardially located cell, the shorter is the action potential, and the shorter is the action potential, the faster this cell reaches the final rapid repolarization phase, where a cell restores positive charge. In the next part we will see how it happens.